The next property is called the quotient property, where we have b to the m divided by b to the n. So we're dividing. So when I divide, I subtract my exponents. So an example here is if you had 5x's on the numerator and you had 3x's on the denominator. If you think about this as 1x divided by 1x, well, that divides out to 1. And another copy, that divides out to 1. And then another copy divides out to 1. If all of those copies divide out, how many do you have left? Well, I have 2x's on top, which another way of saying that is x squared. So the fast way of writing this is just to take the top one minus the bottom one to get x squared. I would also like to talk about the opposite case where we have x cubed on top and x to the fifth on bottom. If you work that out, where we have 3x's on top and 5 on the bottom, well, when I multiply them out, this pair multiplies to 1, this pair divides out to 1, and this pair divides out to 1. I'm left with 2x's on the bottom. And that results in 1 over x squared. So if we apply the same rule, if I have x to the 3 over x to the 5, and I subtract my top minus my bottom, that gets me x to the negative 2. And x to the negative 2 truly is 1 over x squared. So this does work. Another way to think about that is if you have more on the bottom than you do at the top, I often just take the big one minus the small one, and the leftovers need to go wherever the bigger one was. So if we have 3 on the top and 5 on the bottom, if I take 5 minus 3 and that gets me 2, I just know that the 2x squared goes on the bottom because that's where the bigger number was. So instead of having negative exponents, which could be a little bit tricky for students and possible places where you can make errors. So on this first problem, b to the 10 divided by b to the 4. Because I have b to the 10 over b to the 4, I know I'm going to be subtracting my exponents. If you think about it in your head, I'm not going to write out 10 b's, but you can kind of think, okay, if I have 10 b's on top and 4 b's on bottom, 4 of them are going to cancel out. How many do you have left? 6. And where are the 6? They're in the numerator. Alright, let's do this again. Going to do my x's first. I have 3 x's on top and 7 x's on the bottom. After I cancel out or divide out my x's, how many x's do I have left? Well, subtract your exponents and get 4. Where should those 4 end up? Well, they're going to end up at the bottom. And the reason they're going to end up at the bottom is because the x to the 7 had more x's in the bottom to begin with. Now let's do the y part. So I have 6 y's on top and 4 y's on bottom. After you cancel out all of the y's that you can or divide them out to 1, you had 6 on top, 4 on bottom. That leaves me with 2. Or just subtract the top minus the bottom, and that leaves me with 2. Where should they go? At the top, because the 6 was bigger, so the leftovers go with the bigger number. Okay, this one's a little bit tricky, and you may not think of it quite like a quotient property because of the negative 2. But the negative 2 and the negative 2 are a common base. If you think about the parentheses, because the parentheses are the same, I have 3 copies of the parentheses on top and 7 copies of the parentheses on the bottom. After you divide them out, how many copies of the parentheses do you have left? Well, you're just taking these two numbers and subtracting them and get 4. So the negative 2 in parentheses, to the 4, the leftovers go in the bottom. And the reason they go in the bottom is because there was more in the bottom to begin with, because 7 is bigger than 3. And now I can just work that out. That's just 1 over negative 2 4 times, which turns out to be 1 over positive 16. On the next example, we have the distributive property. Now this is going to save you a lot of time here. Whenever you have 2 bases inside of the parentheses and you have an exponent, the exponent gets applied to every single base. So that's going to be a to the m, b to the m. So on this example, just to make sure you understand why this rule works, if I worked it out longhand, I get xy times xy times xy, and then if I rearrange it, I can get 3x's times 3y's, which gets me x cubed, y cubed. Now no one wants to do it the long way. We all like the rule. So the rule just says the exponent gets applied to every single base inside the parentheses. So on the first problem, we have a squared b to the fourth cubed. So that means a squared is being cubed. So we're also going to use the power property because I have a squared being cubed. So that's a to the 6, I'm going to multiply. And then b to the 4 to the 3, I'm going to multiply those and get b to the 12. And that was a whole lot faster than writing out 3 copies and then grouping them somehow. So on the next problem, we have 1/3 x cubed y to the 5th squared. The hard part here is students might think that there's only 2 bases. They can clearly see that the x is a base and the y is a base because each of those has an exponent. But the 1/3 is also a base. So we have 3 bases here. The number and then every other variable. So I have 1/3 squared. X cubed squared, that's really x to the 6. And y 5th squared, that's y to the 10. So 1/3 squared is 1/9 x to the 6 y to the 10. Please remember that numbers are bases. Even if they don't look like they have an exponent, they have an invisible exponent of 1. The next property is the expanded distributive property, which applies the distributive property over the fraction bar, which is basically the same thing. So if I have x over y cubed, that's x over y times x over y times x over y, which gets me x cubed on the top and y cubed at the bottom. So again, the fast way is just to do the exponent 3 gets applied to everybody inside the base, whether they're a numerator or a denominator. It's all equal opportunity here. So on the next problem, we have a 2 and the a are both inside the parentheses, which gets me 2 cubed over a cubed, which is 8 over a cubed. Please be careful. If you have a problem like 2 cubed over a, notice that the parentheses on this problem is different than the parentheses on the original problem that I gave you, because the parentheses on the first problem goes around the whole 2 over a, where the parentheses here is only in the numerator. If it is in like this bonus problem I just gave you here, this is bonus, okay? It's not part of that problem, it's just an extra problem. That's going to be 2 cubed on the top over a, which is just 8 over a. So you have to be careful if the parentheses are covering the denominator or if they're not covering the denominator, because you're going to have different answers. When using more than one exponent rule, you can use them in any order. All exponent rules fall under the E in PEMDAS, so you can use any order that is convenient and used correctly. Now, clearly, you must get rid of the parentheses first, since that's the first step of PEMDAS. But then after that, you can use any exponent rule in any order. Now, even though I give you free rein to use them in any order, I suggest that after you clear the parentheses, you change all of the negative exponents to positive exponents to avoid any negative errors. Again, that's not necessary, but I prefer that order.